Okay, so we're going to take a look at a review of exponential functions and how they work. So first of all, we want to remember what an exponential function is. So an exponential function has a fixed numerical base raised to a variable exponent. And it's really important that we don't mix these up because people have a tendency to do that sometimes in this class. And the issue with that is that, like, look at these two functions right here, y equals 2 to the x and y equals x squared. If you look at the algebra versions of those, they're very similar, right? They both have a 2 and an x. It's just where they are in the exponent. People have a tendency to sometimes mix them up. And the problem is we're going to have a certain set of rules in calculus that we can apply to problems that are in the form of 2 to the x, and we have a different set of rules that we apply to problems that are in the form of x squared. So make sure you're paying attention, and when you're looking at these, what you want to ask yourself is the fixed number in the base or is it in the exponent? If the fixed number is in the base, then it's an exponential. If the fixed number is in the exponent, then it's a polynomial. So different sets of rules for dealing with those two things, so definitely don't mix those up. Okay, and we want to focus on exponential functions. So exponential functions all have the same basic shape as what we see right here on the screen. Now, we could apply transformations that we looked at before and come up with all sorts of different versions. But if you're just looking at your basic exponential function, they're going to obey this kind of behavior right here. In fact, let's put a few more on the screen. And you can see those are all pretty similar to each other, right? There's definitely some similarities. Over on the left side of the screen, they're kind of bottoming out and approaching the x-axis, right? That's our horizontal asymptote over here. And then they all go through this point 0, 1, which makes sense. If you think about it in terms of the exponential, if you raised a fixed number to a 0 exponent, you get 1. That's why they all go through the point 0, 1. And then once you come out the other side, these functions start growing incredibly rapidly. Very, very fast growing functions. Okay, so they all have that same basic behavior overall. Now, we've got just 3 here. We've got 2 to the x, e to the x, and 3 to the x. So let's remember, what is e? So e is this special number on your scientific calculator. There's going to be a button for e. It's because it's a very, very important number. And we'll actually learn in this calculus class where e comes from. You may have seen e before, and you may have used it, but you didn't really have the tools to answer the question, who came up with e? How do we come up with that? So e is an irrational number, has infinite non-repeating decimal expansion. So where did it come from? Who figured it out? As soon as we get into the next chapter, we'll be able to define that. But you need some calculus tools to come up with the number e. So shortly enough, we'll answer that question about where it came from. For now, just realize it's a fixed number. And it's a very, very useful number. It comes up in business. It comes in compound interest. It comes up in science. It comes up in probability density functions, all sorts of reasons, and we'll see why. As we move through the calculus course, this number e is going to keep coming up, and it's actually really nice to deal with. That's why it's so important. So we can see then that our e to the x lies in between 2 to the x and 3 to the x, and that's because e lies between 2 and 3. Right? So we can see these graphs having the same basic behavior overall. We can look at the graphs and realize, well, the domain for these functions is negative infinity to infinity, and the range is going to be 0 to infinity, right? Really positive numbers. So 0 with the parentheses, not including 0, but everything bigger than 0 and on towards infinity. That's going to be our domain and range. And they all share this behavior, except there's a slight modification. We also can include values like 1/2. So the base for your exponential function has to be greater than 0. It has to be positive, but it cannot be equal to 1 because that would actually just be the constant function y equals 1. That doesn't behave like the rest of these, so we want to throw that one out. But we can have fractional values like 1/2 to the x, and if we throw that in there, we see we really get the same kind of behavior. It's just kind of flipped on the two sides of the graph. Right? So we can still kind of think of it in that same way. Now, when we're dealing with exponents, you'll notice that on most scientific calculators and most graphing calculators, there are special buttons specifically for the exponential involving e So the exponential base e and the exponential base 10. Because we use a base 10 number system, the base 10 logarithm comes up a lot. And for reasons we'll see as we move through this calculus course, the base e exponential comes up a lot. So you're going to see these, and that's why they have their own buttons. And then correspondingly, when we get to logarithms, those same bases, but in logarithms, are really important too. And that's why, again, they have their own buttons generally on a graphing calculator or a scientific calculator, because they come up a lot. The only other, there's a few other bases that come up frequently in exponential, but it's kind of in specific areas. Like base 2 exponentials and logarithms come up a lot if you're dealing with computer science, because when you're using binary, you just have two things, a 1 and a 0, right? So a lot of your information can be expressed in 2 to a power. So if you're going into computer science, you're going to see base 2 frequently, but otherwise, whatever you're going into, base E and base 10 are the ones you're going to see frequently. And all of the work we did with transformations apply to these as well. So for instance, if we take y equals e to the x and we just tag on like a +2 on the end, then we can predict that's going to be a vertical shift 2 units. And sure enough, it moves it up 2 units. So they behave following all the rules that we've learned so far. Very convenient. Nothing too fancy going on here. Just play around with whatever calculator you're using. Play around with it a little bit and make sure that you know how to use those buttons that involve E and 10 so that you can use those exponentials and those logarithms when you get to that point. If you're not sure, if you can't figure out how to do it, because some calculators are really weird, like they're completely different than other calculators, to try to go through and figure out how to use them, just look it up, like look up a video on YouTube. Just put the name of your calculator in there and say, how do you use exponentials on this? And there'll be some video of someone showing you how to do it. So very convenient. So the exponentials will come up frequently. We also frequently use the logarithm in the same way. So in the next section, when we're studying logarithms, very important as well, but nothing too fancy going on here.